Hi, Azayo and Mpo and Daneo. Welcome. Good to see you guys again. Okay, well, it's 6 o'clock, so I think we're going to start. And first of all, just want to say welcome. And so this is a question and answer session, meaning it is really your opportunity to ask me questions before you have to write your prelim exam. Can I just get a sense from you guys, when are you writing your exam, your maths exam? Can you put it in the chat for me, or just unmute yourself? It's just the three of you here, so feel free to just chat to us and let us know when your exam is going to be. Paper 1 on Friday. Paper 1 on Friday. Okay. All right, great. Paper 2 on Monday. That's great. Benedict also. Okay, just want to fix. Oh, there's 11 of us. Sorry, I just thought it was the 4 of us. That's fine. Okay, so you all have it coming up. Paper 2, paper 1. Sounds like it's Friday, Monday. Everyone else? When are your papers coming? Please give us an indication so that I know how much time you've got left to prepare. Also Friday. Okay. Right. So this week we've got today, which is Monday, and Wednesday. So, okay, so I see we've got some paper 2, some paper 1 still being written. So it sounds like a lot is happening this weekend. This week, not this weekend. Okay. So I think what we're going to do, I'm going to start off by asking for some questions, because this is a question answer session. It's really for you to ask questions. And if there's anything that you want to know, or, you know, if you have a question, I did ask in the message for you guys to send in your questions. I didn't receive any questions via email or via the chat. So if you have a question, please raise your hand, and then we will answer your, you can ask your question. Right, thanks, Asibi. Let's hear, what is your question?
Ma'am, there was this question, it was on finance. So there was this, let's just say it was Muzine. She invested, okay, she deposited 5,000 Rand.
Yeah.
And then after that, she made monthly payments of, let's say, 2,000 Rand. And we were given the interest. So
Yeah.
I didn't know, I knew that I have to use the future value amount for that monthly thingy. And I didn't know what to do with that 5,000. Should I compound it, or should I add it there? Or
Okay, so I'm going to start. I'm just going to write down, this is your question. And this is on finance. And you said the question was, did she deposit 5,000 Rand every month?
No, ma'am. She only deposited it this 1 month. And then after that, she made monthly payments, equal monthly payments of, let's say, 2,000 Rand. I can't remember the actual amount it was.
So she made she deposited 5,000 Rand once off.
Yes, ma'am.
Okay. And then how much did she pay after that? 2,000 Rand a month.
Yes, ma'am.
On a regular basis.
Yes, ma'am.
Okay. And then there was an interest rate, you say?
Yes. I'm just saying any values because I don't remember the values well, but let's just say it was 40%.
So there was an interest rate of some sort. Okay.
Yes, ma'am.
So this part here, the regular payments that she makes, that is an annuity. It's a future value annuity. Because she's saving, right? So that's why it's future value. So that you'll plug into the future value annuity formula straight away. That part's pretty straightforward. Okay. Are you with me there?
Yes, ma'am.
Okay. Now, if she's making this once-off payment, this 5,000, what we're going to do with that is because she's putting it in the bank and she's leaving it there, I assume for the same amount of time as the annuity, we're going to have to compound it. So there's going to be compound interest on that. So you're going to use your normal compound interest formula. So in the end, your final value will be, so the final value of all her money altogether will be her 5,000 Rand. Let's call this a lump sum.
Okay.
So it will be her lump sum with the compound interest plus the annuity. Okay. The future value annuity. Okay. Does that make sense?
Yes.
What you always have to think of with finance is that time is money. So whatever money there is, it has to earn interest in some way. So if she just takes that 5,000 and she puts it there and she leaves it there for a certain amount of time, it is going to earn interest. What you just have to figure out is it just compound interest or is it an annuity? Because it's just a once-off amount, it's a lump sum. So we're just going to calculate compound interest on it using the compound interest formula. And then the rest is an annuity because she's making regular monthly payments. So just always think of it as the fact that the money stays there, it has to earn interest. So you just have to calculate the interest with the money. Okay. How's that, Asibe? Does that make sense?
Yes, ma'am. Thank you.
Okay, great. Thank you for your question. Right. Who's next? Who's got another question for me? No other questions?
No.
Someone's talking. Yes.
Yes. It's a solve for x question. It reads 2x minus 5 root x equals to 3.
2x minus
5 root x equals to 3.
Like that?
Yes.
Okay, who is talking to me? Timothy. Hi, Timothy.
Hello, ma'am.
Okay. Right.
Yes.
So we have to solve for x.
Yes.
Okay. So what do you think, Timothy? What are we going to do here? Do you have any ideas?
I was actually thinking of taking the negative 5 root x to the other side and the 3 to the other side, and then I square everything to remove the square root.
Yeah. Let's see if that works. So then you get, this we're going to go 2x minus 3, 2x minus 3.
Yes.
And then this is 25x.
Yes.
And then you get 4x squared minus 12x plus 9 equal to 25x. And then you bring that over, so it's minus 37x plus 9 is equal to 0.
Oh.
Minus 6 minus 6 minus 12 plus 9 is 25x. Yep, minus 12. I think that's right. Did you get that far?
And I actually messed up my signs at 2x minus. They actually said 2x plus 3. And then on the other one, I said 2x minus 3. So I made a mistake there.
Oh, I see. Okay. Okay, so then you multiply that out. Now I've got not a very nice trinomial here. I'm thinking to just use maybe the formula, or let's see if it can factorize. No, this won't factorize unless we go 4 and 1. No, oh, it does factorize. Okay, so 4x minus 1x, hold on, minus 9, minus 9, minus 36 gives you minus 37 plus 9. Yep, that works. 4x is equal to 1, so x is a quarter, and then x is 9. Okay, right,
Yes.
Everyone's still with us so far. We had this this third equation, so you can take it over to the other side to make it positive, and you bring the 3 over, and then you square both sides to get rid of the square root. And then it's just a bit of maneuvering to get the trinomial by itself on this side, the left-hand side. And then you factorize it and you solve for x. But now what you must remember to do is to check your solutions, because with a third equation, you always have to check if your solutions are working. So, and that's basically checking that what I get on the left-hand side is the same as the right-hand side. So we have to check. So I'm first going to take x equal to a quarter. And if I check, if I make x on this side of the equation a quarter, minus 5, and then you get that. Do I get 3? If you get 3, it's a solution. If you don't get 3, then this is not a solution to the equation. So 2 times 1 over 4 minus 5, 1 over 4 times 1 over 4. So I get negative 3 over 4. And it should equal 3. Do you guys understand that? With third equations, we check our solutions. The left-hand side must equal the right-hand side when you substitute your solutions in. So our left-hand side at the moment, if we sub in x is a quarter, is negative 3 over 4. So this is not a solution. So I know it seems a bit silly, hey? We just went through all that trouble to solve, and then this is not a solution. So not a solution. Okay. Has anyone checked the other one for us? If x equal to 9 is a solution. Just sub it in. What do you
It's
get?
negative 27.
Negative 27.
Yes.
Okay, so that's 2 times 9. So this has no solutions. That's interesting.
Hmm.
So 2 times 9 minus 5 times 9, square root of 9. I get 3. Maybe just check again, Timothy, if you use your calculator. So
Yeah, let's see if I
2
can.
times 9 plus 5 times root 9 gives me 18.
18.
Sorry, minus, not plus.
I think there's something wrong with my calculator.
Whoa, you better fix that before your exam. Here we go. I get 3. So x equal to 9 is a solution. So, yeah. So, Coco, you also got 9 is a solution.
Yes, ma'am, I
Awesome.
did.
Okay. So, guys, this question often comes up. It's actually work you did in grade 11. But if you can do it right and if you work accurately, it's actually quite nice, easy marks, because this will probably count about 5 marks. So you'll get, and they do ask this has been asked quite often. So you get a mark for squaring, for knowing to, or actually taking everything over and then squaring. And then for your trinomial, you'll get a mark. For factorizing, you'll get a mark. And I think you'll get another one for giving the correct solution. Eliminating one solution is built into that mark. So you get the mark for identifying that one of the solutions don't work. So that's your other one. Maybe there's another one in here for squaring. Yeah, but it's normally about 4 or 5. Okay. Right, excellent. Thanks for that, Timothy. I hope that clears up some confusion.
Yes, very. Thank you, ma'am.
You're welcome. Who is next? Ntando. Ntando, I'm ready.
Yes, ma'am. Can you hear me?
I can hear you.
Ma'am, can you hear me?
I hear you, yes.
Okay. Ma'am, my question is about trig identities. Okay, not specifically identities, but it's a trig equation.
Okay.
And it says determine the equation of the asymptotes of the function.
Yeah. Carry on, I can hear you.
So it says g of x
Yeah.
is equal to a fraction of f of x over yes, and then h, open brackets, 2x plus 45 degrees.
Okay,
Yes,
so
in the interval of x is between 0 degrees and 90 degrees.
0 and 90. Is there other
Yes,
information? Is f of x given? Is the function of f of x given and the function of h of x given? Sorry, Coco, can you try and help Ntando? We can come back to a question. Maybe she says she can't hear anything. Maybe she
Sure,
just
ma'am.
needs
I'll private message her and get her back online.
yeah, or if she can even maybe send the question to us.
Yeah, I'll see if I can get it from her. Sure.
Because I think she can hear us, but we can't hear her.
Okay.
Or she
Yeah.
can't hear us, actually. No, she can't hear us.
Yes.
We can hear her.
No, we'll come back to her. Let me try and chat to her.
I want to do this question. This looks like quite a mean question. So let's get the question.
Yeah. Okay.
Okay, cool. Who's next? Who is next?
Ma'am, okay, I'm back. I can hear you.
Are you back? Yay, awesome.
Yes, ma'am.
Okay, awesome. So let's hear the rest of this question. So have they given us functions for f of x and h of x?
Yes, ma'am. So for f of x, it's equal to sine 2x.
Yeah.
And then h of x is cos x minus 45 degrees.
Cos x minus 45.
Yes, ma'am.
Okay. And they say, what is the asymptote?
Yes, ma'am.
Of 2x plus 45.
Yes, ma'am.
Of those two over each other. Okay. Okay. Is this from a paper? Is this from a question paper?
Ma'am, no, I downloaded it from like it's this other website where they retrieve like a bunch of past paper questions and they put it into one. So I don't know specifically from which year it's from.
Okay. Because I think what you have to do, this has to do with, and it's saying, what is the asymptote, right?
Yes, ma'am. Yes, ma'am.
And you sure it's h of x, h of 2x plus 45?
Yes, ma'am. It says
Okay.
g of x is equal to f of x over h 2x plus 45 degrees.
Okay. Because somehow, if it's f of x over h of x, we're going to have to make this tan. How many marks?
8.
8 marks. And all
Yes,
you
ma'am.
have to give is, and that you have to give the asymptote of g of x is f of x over, okay. Okay. What I'm thinking is we need to, because the only way that there can be an asymptote is if we have a tan graph. So that needs to, we somehow have to get f of x to be, how are we going to make that tan? So what we can do, I'm just going to start playing around, okay, because this question is something else and it's 8 marks. Okay. So what do we do when we don't know what to do? Mpho, do you have your hand up? Do you want to ask something related to this question? Or do you want to ask your own question? Kaka, if you can just maybe check with Mpho what. Okay, so what do we do when we don't know what to do? So first of all, we see that there's something to do with an asymptote. We know that the only trig graph with an asymptote is the tan graph. And they give us the intervals between 0 and 90 degrees. We've got f of x is sine of 2x, and h of x is cos x minus 45. So what I'm thinking is, well, asymptote tan is, we know that tan of x is sine x over cos x. So that may be useful. Don't know. I'm kind of thinking it might be because f of x is sine 2x and h of x is cos x minus 45. So now let's start with, there's not much we can do with f of x. F of x is what it is. But somehow we now have to look at h of x, which is this, and this says get it to be 2x plus 45. So we have to fiddle with it. We have to change it. How has it been changed? Well, the x's are multiplied by 2. I see that. And the minus 45 is now plus 45. So let's see what we can do. If I go h of 2x, that means I have to multiply my x's by 2, which means this will become 2x minus 90. Right? Are you with me? Guys, please ask. Okay, Ntando, are you still with me? Okay, Mpo, it's not based on this question. Okay, so we'll get to you, Mpo, as soon as we're done with this one. And then we also have to go h of 2x plus 45. And that gives me cos 2x minus 45. Okay. So if I first multiply by the x's and add 45, then that's what I get. I get to 2x minus 45. Yeah. Okay. Just want to check something quickly. So if it's cos 2x minus 45 cos 2x, you get cos 2x actually. I think where we're going wrong is here. I don't think we must multiply here. I think this is going to work. Yeah. Okay, so we multiply our x's. And then 2x plus 45 gives me cos 2x, which then in fact is sine x sine 2x over cos 2x, which is the same as tan 2x. Okay. So sorry about my mistake there, because I multiplied the 45 by 2 as well, but we're just multiplying our x's by 2. So Ntando, do you understand that this graph of h of x, if we first multiply the x's by 2 and we add 45, then we're actually going to end up with the graph of cos of 2x. And then if you put that over each other, cos of 2x, the sine 2x over cos of 2x, that is actually then g of x, which is tan of 2x. Okay, how's that? Is that making sense? Okay. Whoa, I feel the same. Whoa. Okay, so now we have to say where the asymptote is. So no wonder this is 8 marks. So let's just think. Okay, we'll get to the marks later. Now, where is the asymptote? So that's some heavy stuff. Okay. That's why I asked where this question's from, because if it's an 8 marker and this will definitely be in the realms of problem solving, then it's quite a big question to just say, hey, here it is, do it. Okay. So what you got to know here is your function notation, and you got to know your identities. So tan of 2x, that means how have we changed the normal tan graph? So the normal tan graph, where does it normally have its first asymptote? Who knows? Who can tell us? I'm just going to switch a light on. Come, you guys are writing your exams. Where is the first asymptote for tan normally? I've got the tan graph. Where's the first asymptote? And what do I do in the exam if I forget? What is my backup plan? Who's got any ideas? Calculator. What is the asymptote in any case? The asymptote is where the graph is undefined. So on your calculator, you can check and you can say tan of 45. Could that be it? No, tan of 45 is 1. Is it 45 or is it 90? So tan of 90, that gives you a mass error. Okay, so use your calculators, your backup if you forget. Now, for tan of 2x, where is the first asymptote going to be? If on a normal tan graph, it's at 90 degrees, where is it going to be for tan 2x? 180. Is it going to be 180 or is it going to be 45? It's going to be at 45 degrees, because look, if we have tan 90 is the asymptote, because that's undefined, right? So 90 degrees, x equal to 90 on a normal tan graph is the asymptote. So then if it's 2 times x, what will make it undefined? It will make it undefined if it's 45. 2 times 45 will be the same as tan 90. Therefore, the first asymptote for this g of x first asymptote is at 45 degrees. Okay. Right. Great. Thanks, Ntando. Thanks for that. Oh, first, my spelling is terrible. So is my handwriting. But anyway, I hope you guys can read. Let's go through this again. And let's also talk about how you will approach it. So first of all, so if this is an 8-mark question and you see it and you start feeling a little bit scared, you also need to sketch it. Okay, you need to sketch g of x. Okay, so we'll do that just now. Only for between 0 and 90 degrees. Okay. So let's just talk about what to do with a scary question. First of all, if it's really scary and you don't know where to start, then you mark it, you circle it on your page, on your exam, highlight it or something, and you come back to it later. Okay. Then you start, if you do come back to it at the end, so it's 8 marks. That means 8 minutes max. Okay, after 8 minutes and you can't get it and you still don't know, you have to cut your losses and you have to move on. Okay, so 8 marks, 8 minutes, and that's how you work in your exam as well. You try and do a mark a minute. So if it's a 5 mark question, you spend 5 minutes on it. If it's a 10 mark question, it's 10 minutes and so on. Okay, so if you see this question, so then what do we do when we don't know what to do? We start looking for things that we can recognize. Okay, so we can recognize that asymptote has to do with tan. We can recognize that sine over cos gives me tan. How can I maneuver this thing so that it can look like sine over cos? Okay, and then that's just start playing with something, just start doing something. Okay, even if you just write something down, sometimes it's a mark. Okay, and then normally if you just start playing and you just start working a few things out, then sometimes the answer comes to you. Okay, now to sketch this graph, and we're just sketching for between 0 and 90. And I'm sorry, my sketch is going to be just by freehand. Going like that. We've now determined that the asymptote is at 45 degrees. So where will the next asymptote be? But we're only drawing up to 90, so it's actually not even necessary to bother about that. So this is going to be like that, because that's the tan graph, and then it'll look like that. And we're just drawing for that interval, so that's all we need. Okay, right, thanks so much, Ntando. That made us all think. Anyone else? Who's next? I think, was it Mpo who had her hand up? Okay, great. Mpo, are you ready? Mpo, are you ready for your question? Otherwise, I'm going to pass it on to someone else. Oopsie. I think we can we unmute you? Kaka, can you try and unmute her maybe?
I think we should just give her a minute, ma'am, and let's just see how many other questions we have so long.
Okay.
Yeah. Just so we can gauge time as well.
Yeah. Okay. Who else? Who else has a question for us? We've done some algebra, we've done some trig, we've done some finance. So that's great. Who else has a question? No one else? Okay, we'll wait for Mpo to come back, maybe with her question. What we maybe can do in the meantime is I got 1 or 2 questions here from the 2019 February-March paper. And this is on sequences and series. If you want to spend some time revising that now, you can do these questions. You can start question 2. And then I think in about, let's see, we work on a mark a minute. So this is 5 marks. That's just finding the general term of the quadratic pattern. Yeah, so let's start. Let's all start and do this one. 5 marks, so 5 minutes. And then if you can also think about our Wednesday session, if you want to tell me what it is that you want to work on. So bring your questions on Wednesday as well. But if there is something else, something specific that you want to look at, you can also type it in the chat for me, and then we can look at it on Wednesday. So you can do that as well. So work on your question and type in the chat for me about Wednesday, what you would like to look at. Time permitting. Mpo, I see. Are you able to talk now? No, she's gone again. She gone? Yeah. Okay, so Benedict, you shouting for some calculus, okay, interpretation of graphs. Optimization, calculus optimization, okay. You guys can bring questions as well or email me, hey? I'll put my email in the chat as well, and you're welcome to send it through to me. If you've come across a question in a paper that you want to do, you are welcome to send it through. Here's my email address. And then I can also prepare it for Wednesday. You can ask now, Mpo. It's no problem if you want to ask now.
Hello, ma'am. Can you hear me?
Yes.
Okay. My question is on calculus, ma'am.
Okay.
They say determine dy over dx if y is equals to 3x cubed plus 6x squared plus x minus 4. I'm confused, ma'am. I don't know where to start.
Okay, so we have to determine dy by dx.
Yes, ma'am.
And what did they give us?
Y
Equals
3x cubed plus
Yeah.
6x squared
plus 6x squared. Yep.
plus x minus 4.
To the power of minus 4.
No, minus 4, ma'am.
Oh, x minus 4.
Yes, ma'am.
Okay. So where is this from? Is this from an exam paper?
Yes, 2018 November, ma'am.
Okay. And is it part of a graph question?
No.
Is it on its own?
Yes.
Okay. Okay, so you have to use the short method. to find the derivative. So the derivative is what dy by dx is. It means we have to differentiate this function. So when we differentiate, okay, then we follow our rule that says take the power, the exponent, multiply it by the coefficient of x, the number that's in front of the variable, and subtract 1 from the power. So take the 3, we're going to start with the first term, and we're going to take them one by one and differentiate them. So that is the most important rule you need to know for differentiation. You have to take the power, multiply it by the number in front, and then subtract 1 from that power. That's the most important one. Then the other rule with differentiation is that when you differentiate a constant, it is 0. Okay, so let's begin here. And we take 3, and we're going to multiply it by the 3. That's going to give me 9x. And from the power, I must subtract 1. Squared. Okay, remember, this is a rule you must know. Okay, this is how to differentiate. Okay, can you do the next one for me? Plus 6x squared. If we differentiate that, what would that be?
12x, if I'm not wrong.
Yeah, 12x. Yeah. Okay. And then plus x. Remember, there's a 1 and a 1. So if we differentiate that, what are we going to get?
1.
Yeah, plus 1. And then that minus 4 differentiates to 0. So that is dy by dx. Okay.
Okay.
Great. Thank you. That's a bit of quick revision of short method for calculus. How are we doing with this pattern? Are we done? 5 minutes are up. Definitely. So let's see. We've got a quadratic pattern. When last did you do a quadratic pattern? Should have been this morning when you were studying. Okay, how do we know it's a quadratic pattern? Well, first of all, they tell us very nicely that it is. If they didn't tell us, we would need to check for a constant second difference. So what is the difference between 29 and 15? That's 14. Between 29 and 41, the difference is 12. And between 41 and 51, that's 10. That means our constant second difference is -2, because we go 12 minus 14 is -2, 10 minus 12 is -2. So that means the difference between this fifth term over here and the fourth term will have to be 8. So this missing term is 59. Okay. Now we have to carry on and find the expression of the nth term. Now, there are a few ways to do this. The quickest and easiest way is to know that this is 2a. The first difference is given by the formula 3a plus b. And the first term is a plus b plus c. Is that familiar? Please put in the chat if you recognize that. Okay, good stuff. Got some people recognizing. That's great. Okay, so we're going to start by solving for a, because 2a is -2, so a is -1. And now that we have a, we can do 3a plus b is equal to 14, and a is -1. So then b is going to be 17. I think I got 17, yeah. And then C, we can do A plus B plus C is equal to the first term, that's 15. So A we said is -1, B is 17, and C is 15, and then C, if I take everything over to the other side and just solve, I get -1. Now, it's very important that you end off by putting everything together. If you do A is -1, B is 17, C is -1, and you don't end off by writing what Tn is, you lose a whole mark for that. So that would just be silly. Okay, who got that? Who got that? This question is from 2019 supplementary paper. Okay, Danae got it. Yay, Caitlin. Wonderful. Are you Mide? I hope I'm saying that correctly. Danae got it. Karabo. Awesome. Good stuff. So that's 5 marks for you if you got the first and the second one. And now determine the value of T27. Now T27, that's easy now, right? Because we've got Tn. So we're just going to plug that into the formula. And I think when you work that out, you get -271. Because that's the 27th term. 27th term. Okay. Now remember, you learned you have 3 sequences that you must know. It's your quadratic sequence, it's your geometric, and your arithmetic. I think we have time for this geometric series quickly. Yeah, let's quickly do this geometric series and then we can call it a night. Okay, so we've got 4 marks, so 4 minutes. So you have to be done by 1856. Okay, I'm going to do the first one so long. So the common ratio is, remember when we do common ratio, that's T3 over T2 must equal T2 over T1. So if you take T3 over T2, that gives you R is -1/2. Okay, so there's that. 2 more minutes. If you are done, then just put your hand up, please. Okay, time's up. Let's see. Right, so we are going to start by just write down what it is that you're looking for. You're looking for the nth term of a geometric series. So the formula for that is Tn is a r to the power of n minus 1. They've given us what Tn is equal to. It's 9 divided by 4096. We know what A is. A is 36. We can substitute R as well. It's -1/2. And it's n minus 1. Okay. So, how's it looking so far? Did we get that far? Okay, now I want everything with a variable to be by itself, just like a grade 8 equation. Variables on one side, numbers on the other side. So I'm going to divide by 36. And this is, again, your calculator, 9/4096. And we divide that by 36, and we get this number, 1/16384. Okay, so now we're stuck with this exponential equation, right? And for exponential equations, we can only solve them if the bases are the same. So we have to take this 1/16,384 and make that to be to the base half. Now, luckily, you don't have to figure that out for yourself. You can, again, just use your calculator. And into your calculator, you can say, I'm just going to carry on this side, 1/, and you put into your calculator, you'll see that it gives you, do you guys know how to do that on your calculator? You go on your calculator, you punch in 16,384, and you say shift, and there's a button there that says fact, F-A-C-T, shift fact, and it will convert it for you to 2 to the power of 14. As I say that again, that's if you want to put something in its prime number base. You take your calculator, punch in the numbers 16,384, 16,384 equals shift and fact, and it'll show you 2 to the 14. Why do we make it -1/2? Because the 14 is even, it's going to come out positive. Doesn't matter, okay? So that's why we can just change it to a -2 at the bottom, to the power of 14. And I guess I should have probably explained a bit better over here, where it's -2 to the 14, like that, and then we take the whole base and we make it to the power of 14. That's just your exponent rules. It says that you can do that, okay, when you're working with a fraction. Now, bases are the same, and we can get n minus 1 is 14. We take the 14 and the n minus 1, put it equal, and then n is 15. Okay, did anyone do that a different way? You could have used a log, I think, if you know how to use logs, but otherwise maybe steer clear of logs unless you're using it in finance. But you could have used a log as well. Right, that's it. Grade 12s. Any questions about this before we all go away? Anything that you're wondering about? All good. Okay, please just quickly take a moment and type in the chat for me any specific topic you want to look at on Wednesday. We've had calculus and calculus optimization so far. Anything else, please put that in the chat. And remember, you can submit your question by email to me or via the app chat. Functions, always the big one. Functions. Calculus. Those of you who are writing paper 2, please shout if there's something you want to do on Wednesday. We can do a paper 1 question, a paper 2 question. Please shout. 3D trig, okay. Remember, CJ, Uzai, you guys, you can send your questions in, okay? You can send them to me if you have a question. Okay, great. I think that's it. We'll call it a night. Thank you so much, everybody, and good luck with all the studying. We'll see you Wednesday. All right. Bye-bye. Thanks, Coco.
Bye, everyone. Thanks, Marlies.
Bye-bye, ma'am.
Bye, Paul.
Bye, Mpo.